Hi there, welcome to this video today. In this video, I'm going to show you how to set up your local development environment with Kubernetes. If you are using Kubernetes in production for managing and deploying your microservices applications, then you probably want to replicate that same environment on your local machine. That way you avoid any last-minute surprises when you're trying to take your application to production. Very quickly, I'm going to show you a quick demo of the kind of setup that we are aiming for. I'll first show you really quick our code structure. So in this is our root folder, KH setup. Say you're creating an e-commerce application and you're going to follow microservices architecture. So you're creating a separate service that is solely responsible for your products and the catalog and all of that kind of thing. And then you have a separate service for cart, which is responsible for, let's say, keeping track of users' cart and communicating with the database that is appropriate for the cart. And similarly, you can have many more services, but for the purpose of this demo, I'm creating two very basic Express applications. And if I open the products file in the src, open index.js, you can see that I'm creating an Express application, and it is going to respond to this endpoint /API/products with the message hello world from products service. And this application is listening on the port 3000. Similarly, if you go to the cart index.js, you will see that this is a separate Express application listening on port 3001, and it will respond when it sees this endpoint /API/cart with the response hello world from cart service. Let's see this in action. So now, as you can see, I'm on this path shop.com/API/cart, and when I hit that, I'm getting this JSON response, and if I go to /products, I'm getting this. Now what I'll do is I'll add some change here, save the file, and if I hit the refresh, immediately you will see the file changes there. And this is amazing when you consider the kind of complexity we have added to our setup with the whole containers and the Kubernetes deployments and things like that. And for this purpose, we are going to use a tool called Skaffold. Let me show you Skaffold. Okay, so Skaffold is responsible for watching for your file changes, syncing your code with the containers and all of that. So in this video, I'm going to take you step by step all the way from creating the application from scratch to configuring the right routing rules and setting up Kubernetes clusters, and then finally setting up Skaffold to watch for the file changes. So I really hope that you find this video useful, and if you do, please do not forget to subscribe to my channel. Thank you. Okay, so I just realized my resolution was not adjusted for the screen. So I have just adjusted that, and moving forward, you should see my screen more clearly. Anyways, so moving on, before I get started, I just want to make sure you have the right environment on your machine to follow along. So the first thing I want to check is that you have Docker Desktop installed on your machine. I'm personally going to use Docker Desktop, so I'll be posting the link in the description. If you don't already have it installed, just visit that link and you will find that you have installations for all the different operating systems. Just find yours and follow the installation instructions. Now, I already have it installed on my machine, so on the top right corner, as you can see, there's a Docker icon. Click on that and you'll see Docker Desktop is running. Kubernetes by default is not turned on, so you'll have to go to the preferences. On the left hand side, you'll see Kubernetes. Click on that and enable Kubernetes. Once you apply and restart, you will see that Kubernetes running symbol there. Close that, and then just to confirm, you can go back to the terminal and just type Docker. Once you type Docker, you should see all of these commands, and that means your Docker is installed correctly. And to check if Kubernetes engine is up and running, you can just type in kubectl get nodes. and you will see at least one node here, Docker desktop, and it's in the status ready. Now, the second thing I want you to check is if you don't already have an account with Dockerhub, just visit this link, hub.docker.com. Once again, I'll post this in the description. So visit this link and sign up for an account. Once you have an account on Dockerhub, just go to your terminal and type docker login. And if this is the first time that you are trying to log in, you will be asked for your username and password. Just go ahead and provide those details, and then you'll see login succeeded. At this point, your environment is all set up and ready to go. Next, I'm going to walk you through all of the steps that we are going to take, starting with creating two different applications, products and cart. We are going to write out Docker image files for both of them, and we'll create containers from these images. So at this point, we will test our application with the containers, and if everything is successful, we're going to push our image to Dockerhub. Once the images are pushed to Dockerhub, we are ready to start writing out our Kubernetes configuration files. So we are going to write out configuration for deployments, and these deployments are responsible for generating the number of pods that we specify. So for the development purposes, we can just create one pod for each of our application. And once these pods are created, they use the image from Dockerhub, they pull the image and spin up the containers. Once these pods are running successfully, we need to expose them to enable communication with our application. So for that purpose, we are going to configure something called as cluster IP service. And they are responsible to enable the communication within the cluster. So at this point, if you were to spin up another container or another pod inside the cluster, it will be able to make a request to our application and receive that JSON response. But to make it available to the outside world, we are going to create something called as Ingress. Ingress, unlike other objects, is a controller which is not built in with Kubernetes. And we have to, actually this is an open source project, we have to install Ingress in the cluster. Once we install it, what we have installed is Ingress controller. Similar to the deployment controllers and replication controllers, they have some intelligence built into them. But to add some rules and specification, we still need to create Ingress object. So we are going to write out Ingress file, and that will, and in that file we are going to specify all the path names and how the request is going to be redirected to those services. So let's say if we have /API/products, we want it to be redirected to our products application, and if it is /API/cart, we want it to be redirected to the cart application. So this is where we are going to add all of the configuration. When we hit that shop.com domain, which by the way, it doesn't belong to me, I just add it in our host file, and this domain is actually mapped to localhost 127.0.0.1. That's the IP address of localhost. So it will reach out to that, and that will get redirected to Ingress controller. Ingress controller will then look for the path name, and then it will redirect appropriately. So this is the overview of the setup that we are going to do, and outside of all this, we are going to also set up Skaffold, and which will watch for all of these changes and accordingly take the decision to sync the code or rebuild the images. Alright, so now that we have clarity on how we are going to approach the setup, let's start diving into the code and look at all the exciting stuff. So I switched back to the terminal, and as you can see, I just initiated a fresh directory, and there's no code right now. So we are going to start from complete scratch. Let's create a couple of directories, products, cart, and then we are going to enter the products directory. Let's start with the products first. I'm going to initialize the project with npm init-y, and I'm going to add a couple of dependencies like nodemon and express, basic ones. All right, once these are installed, I'm going to create another directory called src, and this is where we are going to add our index.js file. And I'm just going to paste the Express application here. As you can see, it is targeting API/products, and it will listen on port 3000. Alright, very quickly I'm going to modify the package.json file to add another script. Start, and when we hit npm start, we want nodemon to start watching for this file. Okay, so now if I do npm start, as you can see, we are listening on port 3000. Let's go back to the browser and API/products. So we are successfully getting this message from the service. Let's stop that, and this is the same way we are going to set up cart. So what I'm going to do is clear the screen, and I'm going to copy everything from products to the cart folder. And now if I cd into the cart folder, as you can see, everything got copied over. We just have to modify a couple of things here. So vi src index.js, and here we'll be listening for the URL API cart, and in response we'll send it back cart service, and we'll be listening on port 3001. Okay, perfect. Let's save that. And now if I run npm start, it is listening on port 3001, and let's just confirm it. Cart. And yeah, we are getting response successfully. Okay, so at this point we have just completed step number 1, where we created both of these applications. So let's go back to the terminal and close the connection. And let's quickly take a look at the steps. So next we are going to write out Docker file. Let's do that real quickly. Clear the screen. So I'm currently inside the cart folder, and this is where I'm going to add Docker file. Make sure it starts with capital D and there's no file extension. So I'll paste all the code here, and then we'll go through it step by step. So what helps in imagining and visualizing these steps are, think of when you have like a fresh Linux machine. Okay, to create any kind of applications, you need to install certain environment. And if you're creating, let's say, Node application, you would make sure that you have Node installed on your machine. And that is exactly what we are doing here. So the first step is from this image, Node version 10 Alpine. So we are first making sure that our container has Node installed on it. Then, just the way we do on our laptops, we create a fresh folder for any kind of project. That's exactly what we are doing here. We'll create another directory called app, and we'll first copy our package.json and package.lock.json inside the app folder. Once we have that, we can now install all of the dependencies. So we just run npm install. So in the next step, we copy over all of the other files and folders into this folder /app. The way we break down is, like, we could have run copy ... at the top, but why we don't do that is because it takes a long amount of time for node modules to be copied over inside the container. And not just that, whenever we are trying to run node application or this Docker container, we always have to make sure that these dependencies are first installed on the host machine, and only then we can create these containers. So we don't want that kind of dependency on the host machine. So in this case, what we do is we only copy these files and let it install from the web, and then we copy over all the other files. Once we do that, we just start our application with the same command that we have been using, npm start. Okay, so I'm going to save this, and essentially this is the same file, same exact file that we have to create in the products directory as well. So let me go back to the products and save it. And now we have in both of these applications. We are going to quickly build images for both of these Docker files that we just created. So the command for that is docker build and dot. Dot is basically the path where the Docker file is located. So with dot, we are just telling that Docker file is in the current folder. And if we hit enter, you will see that the Docker image is being built. And once the image is built, the name of the image is this kind of randomly generated unique ID. But since this is difficult for us to remember, what we can do is we can tag these images. So what we'll do is -t. And the way we tag, the convention is, let's say if you're going to push this image to Dockerhub, we have to first use our Dockerhub username. Mine is Amori Codes. You can replace that with yours, and then the app name. And don't forget the dot towards the end. That's the path to Docker file. And as you can see, this image is now also tagged with the name that I provided. So, oh, actually I provided the wrong one. I'll have to products. Okay, so as you can see now, the tag now this image is tagged with Amori Codes /product. And to run this image, what we are going to do is docker run Amori Codes /products. And as you can see, the application is running. But if you try to access the application from the web, let me go to the products. You'll not be able to reach it because it is completely isolated once again. So we need to map the port on my machine to the port on the container. Let me show you. Docker run -p. -p is the flag that you provide for mapping the ports. The port on my machine is 3000, and on the container it is listening on 3000. So we do that, and the name of the image, press enter, and now if you go to this URL, you'll be able to get the response from the application. Now similarly, if we go back to the cart, cd cart, and if I give it this tag cart dot, it has successfully created this image. And now if I run docker run -p, but if you remember, for the cart it is listening on port 3001. So we are going to do that Amori Codes /cart. And now if we go to 3001 /cart, we get the successful response. So at this point, both of our Docker images are perfectly fine, and we can push them to Dockerhub. So we are going to do docker push Amori Codes cart. This is the first one I'm going to push. And once this is pushed successfully, then I'm going to push the next one, that is Amori Codes /product. I'm going to pause the video real quick here, and I'll be back once this is done. So our cart image is pushed to Dockerhub successfully. Let's do the same for our products. So /products. Alright, so both of our images are pushed successfully, and to confirm that, we can go back to Dockerhub and just refresh. And as you can see, I have both of these images, products and cart. So far we have been successful, and let's quickly look at our steps. So we have just finished pushing our image to Dockerhub. At this point, we can start writing out deployment files. So let's get back to the terminal. And what I'll do is, for this particular app, I'll go to the root of our application, clear the screen. As you see here, we have these two microservices here. So I'm going to add another folder here called K8s and cd into that. So this is the folder where I'm going to add all of my configuration files so that it's all going to be in the same place. So firstly, we are going to write out deployment file for the products, then we'll write out the deployment file for the cart. And I'm going to name it as products-deployment.yaml. Now there are two ways to generate a deployment file. One is you write out all of the specification in the file itself, and the second one is using imperative method, where you give a command and that will automatically generate a file for you. So let me show you the other approach also. So kubectl create deployment. Deploy is the shorthand for deployment, and the name of this will be products, and the image that we are going to use is the one that we just pushed, amoricode/products. And what we want is, we don't want to right away create this deployment, we want to first generate the file. So we are going to dry run it and output the specification in YAML format, and then copy that into products definition.yaml. Now if I open the products deployment, products definition, you can see all of this is generated for us. So firstly, I'm going to just clean up everything that we don't need. Alright, so everything here should make sense now. The kind is deployment, metadata name products. We can give it any name, and when we actually inspect the environment, we will be able to then, based on the name, identify the kind of object that it is. So name appropriately. And the number of pods that we want to spin up, for this purpose we just want 1. We'll give it 1, and the label that it will look for is the app products, and this is the same one that we match on line 13. So line 13 is where we are defining the specification for the pod itself. So from line number 10 all the way to the end is the specification for the pod, and previously everything from 9 and before is the specification for deployment. Okay, so this deployment will look for the pods with the label app products. Okay, and this is what we are going to give the same name to our pod as well. And in the same file, what I'm going to do is add the service as well. If you remember, we have to configure cluster IP service. So I'm going to copy that here, paste here, and as you can see, this is a product service, and the selector is the main thing. Make sure this selector matches the selector that we have given to the pod. So app products, and if you remember, the target port is 3000. So we just assign the port 3000, and the target port inside the container is 3000. Let's save that, and now if we create products definition.yaml, you'll see that both service and deployment is created. What I'm going to do quickly is just to show you that our app is currently accessible from within the cluster. I'm going to create a very temporary pod, and from that pod we are going to try and make a request to our products service. So the command for that is krun nginx. We're going to create a pod with an image nginx, and this rm flag is basically for telling that we just want this pod to be temporary. Once we exit, it needs to be deleted, and then we are going to enter into the shell. Once the container is created, and now you'll see that we are inside the container, clear it, and we are going to make a request to our products service on port 3000 /API/products. Oh, sorry, curl products service on port 3000 /API/products. And as you can see, we received the message successfully. So at this point, our application is accessible from within the cluster. Let's exit it. As you can see, this pod is deleted. Similarly, we have to write out the definition file for the cart as well. It's going to be exactly the same as the product's definition file. Okay, so let's go through each line quickly. All we are doing here is changing the name to cart. Replicas remain the same, and match labels, again, we give all the pods related to this as cart label, and the image we are going to use is amoricodes/cart. Then we also define the service for it, and this service is meant to listen on port 3001. Perfect. Now let's save this, and once again we create from this definition file. Now if you inspect the environment, get all, you'll see that we have both the services, cart service and product service. Each of them is of type cluster IP, and these are the IP addresses. One is listening on port 3000 and one is listening on 3001. We also have both the deployments, cart and products. What deployment does is it spins up replica set, and replica set is the one that is responsible for spinning out pods. And the core function of replica set is to always make sure that whatever the number of replicas that we have defined in the specification is always maintained. So if I were to delete this pod, it will detect that the desired number is 1 but the current is 0, so it will immediately try to spin up another pod to replace this one. And we have the pods in the status running. So at this point, our application is running and it is accessible from within the cluster. Now let us take a quick look at all of the steps that we have done so far. So we created our application, we created Docker file for it, and pushed our image to Dockerhub. Then we also created the pods and the cluster IP to expose these pods. The next step, we need to configure Ingress controller. So as I told you before, Ingress is not something that's built into the Kubernetes, and it's a third-party project, so we need to add it to our cluster. I will be posting the link to this documentation for Ingress Nginx. As you can see, what we are going to install is an Nginx Ingress controller. Now Ingress controllers come in different flavors, but the one that we are going to use is Nginx one. And under the installation guide, you'll see that we have Docker for Mac. So just copy the whole command here and go back to the terminal and paste it. Just if you see the command kubectl apply-f and the path to the file. So it's just like one of the object files, like definition files that we have been using so far. So we can either use like kubectl create-f or kubectl apply-f. And as you can see, it has installed all of these different services, some clusters, some service account, namespace, and all of that for Ingress. Let's clear the screen, and if I do this, get services across all namespaces, you'll see that Ingress has created its own namespace, Ingress Nginx, and this is where it has its own controller and service installed, cluster IP, load balancer. So what it does is it configures two types of services for us. One is load balancer and one is cluster IP. As I told you, load balancer is something that is external to cluster and it remains outside of the cluster. So as you can see here, it is mapped to localhost and our cluster IP resides within the cluster. Okay, so just clear this, and now we are going to write out definition for Ingress. So in the same folder as our other k8s file, we are going to create ingress.yaml. So let us go back to our documentation and I'll post the link for this as well. So you'll see the basic usage. Okay, so just from here we are going to copy until this separator here, because we are only going to configure one Ingress service. Okay, and just paste it here, and there are some things that we need to change, obviously. So the name, first we're going to change it from Ingress My Service to Ingress Shop, and the host we are going to give it shop.com, because this is the domain, and I'm going to add this domain to our etc host file. Okay, and the backend, so for the path we're going to give it like API/products, and this should be mapped to the service name products-service. As you can remember, the service port for this one was 3000. Okay, and as you can see, paths is basically an array, so we can add multiple paths to it. And so we are going to copy this, paste it here, and I'm going to change this one to cart. So whenever we go to /API/cart, we want it to be redirected to cart service and on port 3001. That is all we are giving here, and save the file. And then if we do create ingress.yaml, it is right now created. So we still need to add that one thing like shop.com to our etc host file. So in my case, I have to do sudo, because I can only change this file as a super user. Sudo vi etc host. This is the path. Provide the password. And as you can see here, 127.0.0.1, I've already added this domain shop.com. Now what happens is, like, you don't really have to own this domain. I can even change it to something like google.com and it will work. So the way it works is basically when you type shop.com, it first checks in your etc host file. If it doesn't find the domain here, then it will reach out to the external DNS server, which is like the global DNS server, which will then resolve it to the correct IP address. Similarly, if I were to add google.com, it wouldn't go to the actual google.com. It will check for the IP of google.com in this file. If the entry is there, it will just look for the server on this IP address. Alright, so now just save the file. And now if we go back to our browser and type in shop.com/API/products, as you can see, we are getting successful response. And if we do the same thing for the cart, hello world from cart service. As you can imagine, this already makes our life so much easier, because our front end doesn't need to know what port it is on, whether we are calling two different backend services or whatnot. All of that is abstracted away from your front end. All it knows is it has to reach out to this domain shop.com/API and /whatever it wants, products, cart, whatever. Perfect. So we have reached this step where we have configured our Ingress successfully. Now the only thing we are left to add is the Skaffold tooling, which will watch for the file changes, because currently if you make any changes, they will not be reflected in the browser. So very quickly, what I'm going to do is I'm going to go outside of this folder into the root of my application. So I'm at this root, and I'm going to first look at installation of Skaffold. Okay, so once again, this link I will be providing in the description, and under the docs install, you can see that you have installation instructions for all the different operating systems. So for me, it's Mac OS, and I have already installed using brew install Skaffold. Please go ahead and install this. And once you have it installed, I can just confirm it by typing Skaffold in the terminal, and if you see all of these commands, that means it's installed successfully. And once you have that, let's clear the screen. In the root of our application, just type in Skaffold init. And then you will be asked certain questions. So choose the builder to build image. So Amory codes/cart. So So of course we are going to use Docker file, which is located inside the cart. Press enter. Now it will ask to choose the builder for this image, amoricode/products. Once again we have products Docker file. Click enter and it has generated a file for us. Once we give it yes, enter. If you see now, we have scaffold.yaml. Okay, so clear the screen, open this file, and you can refer to all of the steps that are mentioned over here in this API references. Okay, so as like with anything in Kubernetes, the first line is always API version. So make sure it is copied from here. The kind we are going to use is config. Metadata name and identifier for the project. So I'm going to change the name. So just do like shop scaffold. All right. Now, if we go to the build artifacts, we can see that image is correctly mentioned here because it asked us for that. And we can give it the context. So context in this case is going to be cart. So it will look for the Docker file inside the cart folder. Okay, and if you see here, we have this option of sync. So local files sync to the pods instead of triggering an image build when modified. If no files are listed, sync all the files and infer their destination. So this looks like an option that we want to use for watching and keeping our code changes in sync. So I'm going to go under context and I'm going to add sync. Let's see what's next. Manual sync rules indicating the source and destination. Perfect, I want that. And you have to be very careful when it comes to YAML. The indentations are very important. If so far you have had any errors, please make sure that your YAML files are done correctly. And I'm going to push all of this to GitHub, so if you face any issues, you can just clone from there and use that. Okay, so under manual, we have to define SRC and destination. So once again, it's an array, so you do that, SRC, and we are going to go into SRC ****.js. So it will watch for all of the JavaScript files under the source folder inside cart directory. Okay, and the destination, we're going to give it dot. What that means is inside the container, if you remember, we created /app folder, right? So it's going to just take these updated files from here and copy it in that directory. All right, so we're going to do the same thing for the products as well. Sync manual src ****.js, and destination will be current folder. Okay, save that. And now if you run scaffold dev, you will see that it will first kill all of the pods that we had already running in the background. It will kill that and it will try to restart all of them. So it will try to restart your service, the deployment and everything, so that it can watch for any changes across the cluster. This will take a while, so let's take a break and I will come back once this is done. So welcome back. If you guys are seeing this error like I'm seeing here, don't worry about it. It happens the first time, so once again just try it, scaffold dev, and this time around I'm sure that it'll work out. As you can see, this time around it also built faster, and then you'll see like products and cart, both of these pods are being watched and the logs are being logged over here. So for testing this, now I'll go back to let me open another tab here, and just to confirm that everything is running so far. So I'm on the cart service. Let me change something there. So cd cart vi_src index.js, and I'm going to modify the message. So Nothing to see here. Save that, save the file, and if you refresh the browser now, nothing to see here. So sometimes it does take time for it to build because it does go through some changes and then copies it inside the container. But let me show you again how quickly it goes through. Once again, let's open this file, and this time around, once again, hello from cart. Okay, let's save this, and quickly we'll change the tab and see what happens in the background. As you can see, it's rebuilding the image, but it just builds it locally, so it doesn't actually push it to Dockerhub. And it stabilized in 2 seconds. And now if you refresh this, you'll see that the changes are pretty fast. So that's all. We have the setup here, and I hope this video helped you set up your environment locally. If you have any questions, if you face any troubles, any issues, please feel free to drop in the comments. And what I'm also going to do is I'll push all of this code to GitHub and add the link in the description, so you can always go to GitHub and clone all of these files. Stay safe and keep learning. Bye.